You know, when you see a priceless artifact in a museum, have you ever really thought about what it takes to stop it from just turning to dust? It's not just about the fancy glass cases or the security guards. No. There's a hidden science at play, a constant microscopic war being fought to preserve our history from an enemy you can't even see. Okay, take a look at this silver trophy. At first glance, it just looks old and maybe a little neglected, right? But that dark tarnish you see, that's not just age. It's actually evidence of an ongoing chemical attack, an attack that is literally eating away at the silver itself. The name for this process is corrosion, and you can think of it like this. It's nature trying to claw back refined metals, like the silver in that trophy, and turn them back into their original natural state, like ore. For museum conservators, corrosion is the number one villain in the story of preserving our past. So it sounds like a losing battle against the basic forces of chemistry, doesn't it? But what if there was a way to actually turn back the clock on this destruction? To chemically reverse the damage without harming the artifact at all? Well, this brings us to a fantastic case study from the Queensland Museum. They were staring down this exact problem with a beautiful but badly tarnished trophy. And their solution? It is just a perfect example of science looking like straight-up magic. So how'd they do it? The process is called electrolytic cleaning, and the amazing part is how simple the materials are. We're talking hot water, sodium carbonate, which is basically just washing soda, and, believe it or not, aluminum foil. They wrap the silver object in the foil, making sure the two metals touch, and then submerge the whole thing. This kicks off a chemical reaction that converts the tarnish back into pure silver without any harsh scrubbing that would remove the precious metal itself. And check this out. This is the result. On the left, you've got the tarnished trophy, and on the right, the exact same piece after the treatment. The transformation is absolutely stunning. This is the power of what scientists call a redox reaction. It's essentially tricking the corrosion into leaving the silver and jumping onto the more reactive aluminum foil. History is preserved, and the damage is literally undone. So, problem solved, right? A quick chemical bath and everything's good as new. But if it's that easy to fix, what's the big deal? Why is conservation such a massive challenge for museums all over the world? Well, that's because the real goal of modern conservation isn't about these dramatic before and after fixes. It's about something way more proactive and honestly a lot harder: stopping the damage before it even has a chance to start. And this quote right here says it all. The main job of a museum conservator isn't to be an ER doctor rushing in to perform surgery after something's gone wrong. No, it's to be more like a public health expert, creating an entire environment where the disease of corrosion can't even get a foothold. It's all about prevention over intervention. Now, to prevent the damage, you first have to know your enemy. And for museum artifacts, the enemies are often totally invisible, lurking in the very air all around them. And there are two main culprits here. First up is relative humidity. See, even if an object looks bone dry, high humidity means there are microscopic layers of water coating its surface. And that water acts like a superhighway for the chemical reactions that cause corrosion. The second threat? Chemical pollutants. We're talking about tiny airborne gases from things you'd never suspect, like the wood in a display case, the paint on the walls, or even the felt lining a storage drawer. And the effect of that humidity can be absolutely off the charts. Just look at this. This chart shows the corrosion rate for iron. At low humidity, below 40%, corrosion barely happens. But you crank that humidity up past 70% and the rate of destruction just skyrockets. It's not a gradual increase. It's an exponential explosion of damage. And to make things even trickier, different metals have different enemies. Sulfur compounds in the air, from stuff like wool or rubber, will go after silver and give you that familiar black tarnish. For iron, chlorides plus high humidity is the killer combo. It can actually cause the metal to weep these yellow-brown droplets. And lead? Lead is incredibly vulnerable to acids from wood, which can literally reduce a solid object to a pile of white powder. So you're faced with this multi-front, invisible assault. How do museums even begin to fight back? Well, they turn their storage rooms and display halls into high-tech fortresses, engineered specifically to repel these chemical attackers. This is their arsenal. They use incredibly airtight cases to create tiny, stable microclimates. Inside those cases, they use desiccants like silica gel to literally suck moisture out of the air, keeping that humidity low. Then they use sorbents like activated charcoal that act like sponges for all those harmful pollutant gases. All of this is backed up by serious air filtration systems and, maybe most importantly, constant round-the-clock monitoring. And here's what that looks like in the real world. This might seem like a simple storage box, but it's really a self-contained fortress. See those little bags of silica gel? They are actively controlling the environment in there, absorbing water vapor to keep the humidity super low, all to protect that very vulnerable iron artifact. But you can't just set it and forget it. That's where these little guys come in. These digital sensors are the sentinels of the collection. They are constantly tracking temperature and humidity, logging all the data, and they'll sound the alarm if anything drifts into the danger zone. This constant vigilance is what makes prevention even possible. So, here's the big takeaway. The real work of preserving history isn't just about those big, dramatic restorations. It's about this silent, relentless, and invisible battle against chemistry that's being fought on a microscopic level 24 hours a day, 7 days a week, inside every single museum in the world. And all of that brings us to the final, really challenging question. This level of protection takes a ton of time and money. With literally millions of objects in collections worldwide, the real job of a museum isn't just showing off history, it's making really tough decisions about how to protect its future. So when you're faced with the unstoppable march of chemistry, you have to ask, what's worth saving?